what we're looking at here is we're looking at factorising, and particularly what I wanted to look at was factorising patterns. One of the things that makes maths so much easier is when you see the pattern, and especially when you've done it 50 billion gajillion times. I'm going to start just a recap of basic factorising. So factorising means I find a number that fits inside the other. Remember, as I was saying, we had the lovely definitions that a factor is a couple of numbers that multiply to make the bigger number. So similarly, factorising is numbers that fit inside everything. So if we look at this first example here with the factorising up here, put your hand up if you can tell me a number that would fit in both of these. 4 would fit evenly into each of these, which is nice. And what's a letter or a pronumeral that can fit in both of those? Put your hand up if you can figure it out. Yup. Yes, Miss. Yeah, there we go. So X. So 8x divided by 4x would therefore, what would that leave? 2. Yep. And negative 12x squared divided by 4x, what would that leave? Negative 3x. There we go. Splendid. So factorising is about finding what's in common with both things. The next one is one that often causes people grief because there's brackets palooza, which I believe is the name of the festival, and you'll find that it gets very confusing because people say, oh, there's now about 4 different things in here. In my opinion, the easiest way to look at these questions is just be aware that it's still just 2 bits. So if you consider that this, how that was 2 terms there, consider that as term number 1 and consider this as term number 2. What's in common between both of these? Mr. Daniels. X minus 2. So that's the factor. So here's a thought, and I might get my little borders away now that you've seen that. What is 3x brackets x minus 2 divided by x minus 2? What would I have left? Just the 3x. And what is positive 2x, 2 brackets x minus 2 divided by x minus 2? Positive 2. Boom. That it. Factorising patterns. So this is one now, for those I taught last year, I know we went through a lot of these factorising patterns to death, but just in case, for those and for those who went, I can't remember last week, that's okay. We're going to go through some of these now. So this factorising pattern is called the difference of 2 squares. So that in order to see this, I usually like to work in reverse. So I'm going to do some expansion, and you might see what happens here. I've got these 2 sets of brackets here, and I'm just going to expand them as we normally would. So we're going to go shmeh, and shmeh, and shmeh, and shmeh. So that's the technical noise, I assure you. 8 times 8 would be what? No, it's not 16. At this point, we managed to stop ourselves. 8 times 8 is 64. 8 times negative x, what would that be? Negative 8x. Positive x times by 8? Plus 8x. And positive x times by negative x? Negative x squared. Yeah. So if we tidy this business up here, we can see negative 8x plus 8x, what would that equal? 0. So it just becomes 64 minus x squared. So let's look at the friend on the right. So again, we're going to go...
Wait, is that factorising?
No, I am about to show you the factorising in just a moment. Factorising, well, of course, putting things in brackets. I want to show you the pattern where it comes from. Because if I tell you the rule, first of all, it'll be like, what? Okay. So that's why I want to show you this thing. Yeah, Mr. Schwab at the back, whilst I'm doing this.
Because the rule's a squared plus b squared minus b squared, is it better to keep the 64 in squared form?
We can. To be honest, it's if you know what 8 squared is, just tell us the answer.
Okay.
Yeah.
So it's better to keep it if you can.
Yes, that would be super. If it was like 20 gazillion x, y, z all squared, just leave it as that. That would be splendid. So 3 times 3 here will be equal to 9. 3 times positive 2x would be positive 6x. Negative 2x times by 3 would be negative 6x. Negative 2x times by positive 2x would be negative 4x squared. Positive 6x, take away 6x, will make that 0. So it just means 9 minus 4x squared. So I think a lot of people are already ahead of me in this instance because they are able to identify that there is a pattern. As you can see, when I've got, and see 2 8s there, 2 x's there, and the only thing that's different is the plus and minus, then we can see that if I have something squared, take away some other thing squared, this would be the same as, if I want to factorize it, a minus b, a plus b. And there's I'll even put a cloud around it. There we go. See, look at the things I can do. I can put clouds around things. And there's our little factorizing pattern.
Are the clouds included in the budget?
Well, look, I've stretched the budget as far as I can. You could say I'm super serious about it. That's a type of cloud. Oh, I don't know whether to give up. Now, so we're going to look here.
Sorry.
I appreciate it. See, clearly the best people get it.
Included types of clouds. I forgot that was part of the test.
See? This is why, man. This is why. You've got to be ready for clouds. They're coming. Now, so x squared minus 9, if I want to have an idea for 2 sets of brackets, put your hand up if you can idea what would be the lovely m-bracketed form, Miss K. Sorry?
X plus 3, x minus 2.
Yep.
It doesn't matter what order they are in, no?
Nope. As long as one is a minus, one is a plus.
Sorry.
That's all right. You don't have to apologize. It's okay. Just sounds like you may have accidentally discovered some gold under your seat. That's all. Oh, that's where it was.
The gold mine continues.
Well, that's true. It was underneath those clouds.
Like the cirrus clouds?
Yes. Alrighty. So, with this one on the right, what would go in each one of the brackets? Put your hand up if you've got an idea of what would go in each of the brackets. Oh, Miss K, what do you suggest?
4a minus 7, 4a plus 7.
Okay, so where did you get the 4a from? Yeah, that's okay. I just would like to hear what the thinking is, because other people in the class might be like, where the hell did you pull that from? So, yeah, so there. No, it is perfectly fine. I just wanted to know how we got that. So 16, when you're finding what's inside the brackets, when you're finding out what goes in the brackets, you do the square root of everything. So in this case, this was the square root of 16 as well, because the square root of 16 is equal to 4. So the 4 goes in each one of those. The square root of a squared is a, so that's why it goes in there. And the square root of 49 is equal to 7. Okay? And that's how it gets into the brackets. Now, Mr. Daniels, spoiler alert, managed to work out this one here. So could you tell me what your reasoning was here, Mr. Daniels? You had a suggestion on what would be in the two brackets.
X plus square root of 11 and x minus the square root of 11.
You are spot on.
Because 11's it's a weird number. And
You-
so can't
'cause-
square
Prime
it.
numbers.
It is.
Don't we love prime numbers?
Yes, we do actually. They're rather beautiful. But yes, this cannot be square rooted. So therefore, it can just stay as the square root of 11. Like, great. So, with that in mind, how would we work out this other one into two brackets here? Okay, so yeah, there's a 2x here and a 2x there. He said like old MacDonald had a farm. Yep. Well done. Spot on. Okay, so it'll be 2x minus square root of 13, 2x plus square root of 13. And so now that's the factorising pattern. Hooray!